We'll start recording. Testing how it works. All right, good afternoon. Thank you for your patience for waiting for me for posting the syllabus. I finished all the thing last night. The problem is like I couldn't sleep last night, but yeah, I'm here. Yeah. And then like this is an in-person class, but I will try to accommodate like some of the online requests as maximum. So like I will broadcast this over Zoom and also like post the video on YouTube. So there's no attendance check, but I highly recommend come to the class because like the experience of the learning is totally different in person and remote learning. Yeah. Even if we practiced a lot for the remote learning during COVID-19 pandemic, I believe like some of you also felt that like the learning is not like as before. So yeah, so that's one thing. And welcome to the Operating Systems 2 class. So let me start with introducing myself first. So I'm Youngjun, and I've been here for 5 years since October 2017. And my main research area is computer systems security. Yeah. And what I have been done was like the so-called hacking. Yeah. I previously hacked the Intel CPU and also hacked the iPhone. And then if you have ever heard about the jailbreak kind of thing, so like I jailbreak the phone, like the iPhone on 2014. Yeah, it was fun. Yeah, and I also working on like software security, which is like the automatic hacking. So that my program automatically analyze the programs that you wrote and then some other developer wrote and automatically figure out some of the errors and hack the thing. And my recent interest is like the studying in like the blockchain and the decentralized finance, and then try to find the vulnerability in there and fixing them for having more secure world. So like this is the photo of me when I won the DEFCON CTF, which is the world best hacking competition. That is like the so-called Olympics of the hacking. And like so myself looks very happy, but I'm more than happier than like that year in this year because I'm a faculty advisor of the OSU SEC, which is a cybersecurity club of the OSU, and our students advanced to the DEFCON CTF final in this year, and we rented like the $10,000 Airbnb and then used that as a hacking headquarters, and then we enjoyed a great time in there. So yes, I'm advertising the security club right now. So if you're interested in, please join the OSU SEC cybersecurity club. Yeah. And then another classes that I'm teaching is because like I'm a cybersecurity guy. So I also do operating systems, but I teach intro to cybersecurity, intro to security. And like may I ask how many of you are taking CS 370 in this term? There are some of you. And then thank you for sharing around the 4 hours, no, actually 8 hours per each week. So you guys need to follow me to like the Kearney 112, yeah, right after this class. Yeah. And then some other classes that I'm teaching is like the cyber attacks and defense, which indeed teaching hacking. And then sometimes I offer the class called the system security, which teaches some of the tools and applications of the state-of-the-art cybersecurity techniques. So you can always ask any questions to operating systems, but you are also welcome to ask any questions related to cybersecurity. If you have any questions, yeah, feel free to ask me any questions about that. And this is an introduction of myself. And then let me introduce how this class will go through throughout the term. Yeah. So today I will just go over the intro of the class, and then we will start the actual material from like next Tuesday, coming Tuesday. And to start, let me share the goal of this class. So the goal of this class is to learn about how modern operating system works. So I presume that almost all of the students have taken the operating system 1 class, and then that class is for learning how to use the operating system. What that means is that you need to know what kind of functions you need to call to write a file, for example, open, read, write, those kind of the system calls. But you didn't get into how such system calls are implemented. So in this class, we will learn about the internals of the operating systems, and then we will dive into the details of like how each of the such functions are implemented. And then our lab assignment will ask you to build your own operating system. And then it actually boots. If you bake it at the end of the term in the USB drive, then you can actually boot on your laptop. Yeah, so it's the real operating system, and we will do that. And then I heard that many students, many former students and alumni called this class, and then I came to here to prevent you from graduating. So that's not true. Yeah, I'm here to help you understanding the internals of the operating systems. And then this class is organized as 2 parts. So first part is lecture. So during the lecture, I sometimes will introduce some of the code pieces, but I will mostly describe the internals of the operating systems with these kind of figures. So there's no code at all. And then this is a security notion of the operating system, and then there's no code. And then the other diagram shows that like the how the user kernel isolation works, and then how the primitive multitasking works. But I will describe mostly at the high level with those figures. But understanding operating system at the high level doesn't mean that you actually know the internals of the operating system. So there's a famous quote from someone who lives in Portland. Do you guys know who this guy is? Yeah, so the original inventor of the Linux. So the Linux, the name comes from it's a Unix variant of the Linus build. So that's why it is called as a Linux. And then he someday told about like the talk is chip, show me the code. Yeah. So the high level ideas are important, but if there's no code, that's not a working operating system. So like that, I just borrowed this quote to give the importance of like the implementation and then working code of the operating system. And during the lab assignments, we will learn about the engineering details of the operating system. And previously we saw some of the nicely configured figures, but during the lab, what we will see is these kind of code snippets. But don't worry, the concepts that you will learn from the lecture will be directly mapped to these kind of code. So if you follow the lectures and tutorials well, then you cannot get lost. Yeah. And then not just for the C language, so we will use C language intensively. And not just for that, for sometimes, because the operating system here works closely with the hardware, we sometimes need to write some of the assembly code. Yeah. But I know that many of students have experienced the assembly code in 271 or CS271 or ECE 375. Yeah, so the syntax is very similar to that. So, and then like I believe like a writing of assembly, technically we need to write around like the less than 30 lines. Yeah, so like it's not that intensive, but you need to know how the syntax works. Yeah. And during the lab sections, we will learn about that. And an important thing here is that we will not have in-person lab recitation. But But as an alternative, yeah, we will have almost the full coverage of like the from like in 9 to 7 p.m. for every weekday of like a TA support, so that you can ask any kind of questions, any kind of debugging questions to our TAs over Discord. And then I trained our TAs swift and then ready to answer the to your questions quickly. So like so please use Discord as like the your resource for the like the when you get stuck on the doing the lab sections. And the topics that we will cover, starting from like the virtual memory, segmentation, and paging, which is like the memory management. So that these are the thing we will learn for like the first 4 weeks. And then the lab 1 and 2 will cover those topics. And then we will move on to the process isolation, and then kernel space and user space, that kind of the security notion in lab 3. And then we will learn about the synchronization and concurrency, and then implementing multi-core operating system in lab 4. So so for some more objective of this class is like the general goal is like to understand how the internals of the modern operating system works. And after you finish this class well, then you will be able to answer to the following questions. So first, what happens when we turn on the computer? And then how does it boot from the BIOS to the operating system and then running the application? So you will learn that in very detail by following the assembly lines, yeah, to learn about like how each steps are running through. So starting from the bootloader to loading the kernel and then running the application. And then that includes how does an operating system run an application. And then we will also implement the virtual memory system on the operating system. So we will learn about how does an operating system run the application that requires more memory. For example, suppose your operating system only has like the 256 megabyte of the physical memory. But in the concept of the virtual memory, that should not limit the application to have like a 4 gigabyte or 2 gigabyte of memory. So we will learn about like how we can implement such magical thing in the operating system. And another thing is that like suppose your laptops usually these days like we usually have like the quad core CPUs. So that means like your laptop has 4 brains. But in reality, we can run almost like the unlimited number of the applications. For example, you can run like the web browsers with the multiple tabs. I usually have like 30 or 40 tabs open for when I work hard for something. Yeah, but even if with my quad core machine, it can support all the processes running perfectly. Then we will learn about how an operating system manage that correctly to run the multiple applications more than the number of the brain, cores, correctly on the system. And we will also learn about how an operating system have the privilege separation, so protect itself from the malicious software. And also in the multi-core and then multi-threading environment, there is a problem so-called the data racing. And then we will learn about how to synchronize multiple thread and processes each other. And I bet like some of you have already know like how to use locks or mutex in the higher level language, for example, in Python. But we will learn how to implement the lock or mutex itself in this class. So you can briefly thinking that like what we will do is if there's something as a conceptual thing, and then we will get into the deepest low level as possible, and then learn about all the steps inside there. Any questions? All right, then I will move on to some logistics. So I tried to use Canvas in a good way, but the thing was like it's very hard to handle it programmatically. So like I used my own website. Sorry about that. So please visit the website to get the detailed information about the class. Yeah. And then we will use another server. Federal law does not allow me to like store your academic progress information to the outer server than OSU. So I installed the GitLab. So what it is like it manages like the versioning of the like your code. So like it will store your progress making towards like finishing the lab into the my server. Yeah. So for those who have not used the Git before, please try to get familiar to like that system as soon as possible, because we will use this for like submitting all your code, and like that I will fetch all your code automatically to have the grading for the lab projects. And then like this is the link for our lab Discord server. So if you have not registered yet, please get onto the server as soon as possible. And then like our TAs are ready to answer your questions on there. And then for the actual assignment server, we will use the os2.engr oregonstate.edu as the main server. But when the due date comes in, even if the server is with the 64 core, yeah, it slows down. But you don't have to stick with the OS2 server, because all the disk is shared across the multiple servers. So you can connect to the OS1 or old OS1, old OS2, or you can even use Flip server, yeah, to run all the labs. Question? I don't care about the kind of the crash, so like there will be no penalty at all. Yeah, but we should not bother some other like the students' work. Like if the CS344, like if they complain against us, like that could be a problem to me. So like then better to use old OS1 and old OS2. Yeah, these are dead machines. And then like those are not used by like a CS344 as far as I know. Yeah. Any other questions? No. And then we will have the 10 weeks of the schedule. And then I posted the tentative schedule on like this website. Then like if you get there, then you will see the calendar form, and then like there are links to the lecture tutorial and then some of the reading materials in there. And then it also shows the due date of each lab. So the first due date is on October 3rd. So you have a little room to finish it. Yeah, so please don't worry right now. And then for the first 4 weeks, we will learn about the virtualization. So like I matched these kind of notions to the textbook. So the name of our textbook is OS 3 Easy Pieces, TEP. And then the 3 easy pieces are about like the virtualization, concurrency, and persistency. Yeah. But within 10 weeks, we have a limited time. So I will focus on like the more important things than the persistency. So we will use 4 weeks for the virtualization, which means about like the implementing virtual memory and then creating the isolation between user and kernel. And then we will use another 4 weeks to focus on concurrency for running multiple cores and the multiple programs at the same time. Yeah. And then we have textbook, but you don't have to buy it. if you like to read the textbook with paper, physical paper, then you can purchase in Amazon because this is a fully open source textbook. But you don't have to purchase it because like for the related part, I created a link as a read textbook. Is kind of the link here, yeah. So that you can just click them and read that as a PDF. And then like right now I'm recording the lecture, and then like after finishing each lecture, I will upload that on YouTube, but it requires a little bit of processing time. So like I believe like the YouTube video will be available around the 6 p.m. or 7 p.m.-ish of the lecture day. Yeah. So you can take the lecture asynchronously at that time, after that time, or yeah, if you cannot make the class, then you can join a Zoom session synchronously. And then meeting time with me is in-person lecture at here, and also I will open my office hour physically in like the Cali Engineering Center 3079. This is a corner room on the 3rd floor. And then my door will be open for like the 5:30 to 7 p.m. on Wednesday. So please feel free to come by and ask any kind of question related to the computers. If I can ask, I will try to answer at my best. And then if I don't know the answer, then we can search together and then try to get the answer together. Yeah. And if you have questions outside this office hour, then like feel free to send a direct message on Discord. I might not be available immediately to answer your question, but I would like to handle that at the night during the nighttime, or like sometime that I was off. I'm off. Then like there will be a little delay, but I will handle that. So if the TAs and then TAs cannot handle your questions, then feel free to send a direct message to me. And then another important part is like the meeting time with TAs. So there's no physical meeting time, but we will use Discord to interact with the TAs. So we will not have a lab recitation, but we will provide a tutorial video that you can watch and follow at your own time, so that you can do that when you have at the recitation time, because you will not have the classes in that slot, or you can do that at any time. Yeah. And just watch the video, and like if you are stuck on somewhere, please try to resolve it by your own for a little bit of time, but I don't want you to spend too much time on it. Some of the students complained to me about like he or she couldn't fix the one line of the code, and then stuck on there for 3 days, and then like asking for the extension for the due date. But please don't do that. So try to it's okay to like think about like some of the problem for 30 minutes or on 1 hour. But if you stuck on there, and then try to ask for help on Discord to other students or like the TAs. And then this is an example of the student questions. So one of the students, Mask, he asked the questions with the direct message to me, and then specifically about some of the function, and then show me about like how they implemented the code. Yeah. So this is a good example of the asking the question, because like by doing so, I can get the full information about like the situation that you are into. Yeah. So without taking a look at your code or like understanding the environment, because each of students will write their own code to develop the operating system. Yeah, that's very important. And then in that regard, if you are asking questions, something like this, then I can immediately provide like the answer for that to resolve the hurdle, and then you can move forward without like spending too much time on some of the errors. because this class requires like the lots of like headache and debugging, and then like the using of the C language, there are so many memory errors. So we have a TA availability like this. So this is an example for the like, first week, but it will be fixed across each week. There could be a little bit of like the flexibility of the TA might change their time, but the thing is like we will be there almost all of the day for the weekdays. So you can ask questions to the corresponding available TAs via direct message, or you can leave the questions on each lab channel on the Discord. And then sometimes like many students would have like a common questions. Then like we would like to pin the message in the channel. So whenever you would like to ask questions, try to look at the pinned message first. And then if that handles your question, then yeah, then you can handle it in a quick moment. Yeah. And then if you cannot find the answer and the pinned message, then ask questions in the channel first. Then like some other students who also suffered the same problem may assist you or give hint. And I actually encourage of doing that. Yeah. So like the students help each other. That's like power of the community. Yeah. And then that happens. And then if that doesn't help you, then please ask TAs directly for your problem. Any questions about like having Q&As over Discord? All right. And then next is about grading. So this class does not have a midterm or final exam, but instead of that, we will have 70% of the credit comes from the lab assignment. Because the lab assignment requires a significant of your time commitment. Yeah. So that's why like it has 70% of the it's taking the 70% of the credits. Yeah. So please be prepared about like the start. Please be prepared about the starting lab assignment as early as possible, and budget your try to make your time budget well to not to fail some other classes. Yeah, because like if the lab assignment takes like the 40 hours per week for your like time, then like you'd not have like any time to finish some other classes, so that would be the problem. So whenever the lab assignment finishes, then try to take a look at the next assignment, and then try to make a room for the time budget for them. And then like we will have 3 quizzes. Quizzes are mini exam, but so like after finishing each part of the thing, after finishing virtual memory, we will have the quiz 1. And then after finishing lab 3, we will have quiz 2. And then in the meantime of the handling lab 4, we will have quiz 3. But the good thing is that like I will make it available on Canvas, and then it's conducted as a fully open material. That means that you can refer to any kind of slides and textbook while taking the quizzes. But the important thing is like that please don't search on the internet. Yeah, that might give you a direct answer, but problem is like you cannot learn the things inside the question. Yeah. And then like I will open the quizzes, each quizzes for like having up to 3 trials. So what you can do is like take the quiz and then try to study about some of the questions you answered as a wrong answer, and then you can make up at the second time and then third time, and then I will just take the best scores of your like any of the trials. Yeah, and then there always happened that like some students got 10 points in the first try, then 9 points on the second trial, and then 8 points on the third trial. But and then one of the hints that I would like to give you is like when you got the wrong answers and the correct answers, try to capture it all, and then please don't get wrong for the second time or third time. Yeah, I highly recommend doing that. Yeah. So like some of the students like asking me about like having one more trials because like they got like the lower score than like the previous trial, but please don't do that. Yeah. And then like I believe like most of the quizzes are finished in 30 to 40 minutes. And then even if you don't know anything, yeah, if you study right away while taking the quiz, it would take like 60 minutes or 70 minutes. But I often the quiz time for like the 2 hours, so that time will be enough for taking the quiz. So the reason why I'm doing this kind of taking this kind of leniency is like the most important thing is like not about like getting score on the quiz. So the most important thing is like that you actually learn about like the questions, and then like and you will see that like after you got some of the wrong answers, then refer to the material and then get the correct answer, then like you will feel that you are actually learning something. Yeah, I try to like promote that kind of the learning experience to you. So like some of the students like complaining about like quizzes are too easy, but what I'm thinking is like in that way, this way is more inclusive, and then the students learn more about the details. And then I put the tentative grading scheme, but I'll try to adjust the curve based on the like how the most of the students are performing. Yeah, but the fixed thing is that like the graduate students who takes this class as a 544 will have a higher grading bracket than the undergrad students. And we have 4 labs, which takes 70% of our credits. And then first lab is about learning about the booting process of the PC. So it starts with the BIOS, bootloader, and then enabling protected mode, and then enabling the fake virtual memory. But this is the easiest part. So I set the duration of the lab assignment as 1.5 weeks because so I believe like many of students can finish it in like the 8 to 10 hour-ish. But the reason why I set it as like the 1.5 week is like some of the students are not familiar to some of the tooling and the environment that we set up for you. So I know that many students prefers the use of the VS Code and like the visualized debuggers, but there are some practical issues that like our VPN and then some of the network settings are preventing me to set it easily for you. So, and also like if you get into some of the work environment, for example, like after the graduation, if you get a job, then in most of the cases, you need to be in the like a Linux terminal environment to develop some of the code. So I set all the environment in like using the terminal multiplexer, and then terminal-based debugger, and then using the editor for the terminal. So get familiar to that kind of environment takes a little bit of time. So that's why I set the 1.5 weeks for the lab 1. And then if I measure the difficulty of this lab in scale of the 1 to 10, then the difficulty is just 1. And the second lab is about implementing the memory management, which is implementing virtual memory and paging system. And then I allocated the 3 weeks for doing this because it also requires you to get familiar with the JAWS operating system structure. Yeah. And then in terms of the difficulty, its difficulty is scale 2. And then third lab is about like creating user environment, which means like we will create the process, which is the application running space. and then like we will implement some of the system calls and then handling that. And then because at this time, you guys will be familiar to the JAWS structure a little bit after finishing lab 2. So I allocated 2 weeks. And then the difficulty of this lab in scale of 10 is around 3. But the most important thing is that, so the lab 4 is a little difficult. Yeah. So it requires a multitasking. So like the first thing it will do is like it will enable 4 cores. So it used to have just one single core until lab 3. And then enabling 4 cores means like you will see that the 4 people are talking different things in your operating system, and then you need to handle those correctly. Yeah. And also it requires like the handling of the exceptions and then implementing of the inter-process communications. So conceptually, it's a little bit complex than the other labs. So in terms of difficulty scale, it will be 10. But if you follow the tutorials and like follow the pinned messages or like the asking questions to the TAs, you can finish it with the good score. Yeah. So please don't worry much about that. But please keep in mind that you need to work hard for lab 4. So try to finish lab 1, 2, 3 on time. Yeah. And then if you get delay on lab 3 or something, then you will have only 2.5 weeks or 2 weeks for the finishing lab 4. Then it's very hard to finish that in that short time. Yeah. Any questions regarding this slide? And then like historically, I believe around 30% of the students successfully finish up to lab 4. And then another 40% of the students, so the maximum score of the lab 4 is 80. And then, so 30% got the score 80, the perfect score for the lab 4. And then another 40% of students got around the 40 to 50 over 80 for lab 4. Yeah. That's the historical statistics. And to conduct the lab assignment, so we have a web tutorial web page, which look like something like this. So it will have the detailed instructions that you can follow in text. And then it will instruct you need to take a look at which file, and then which part of the code, and which function, something like that. So please follow those kind of the thing. And then at the same time, I provide lab tutorial video, and then like it is designed to follow each of the exercise. So this means the exercise 3, and then lab 1 has a exercise up to 12 or something. But our tutorial video will introduce the step-by-step. So please take a look at the lab web page tutorial, and also the video tutorial at the same time, side by side. Please work with them interactively. And then like all the videos are available in my YouTube channel. And then many people says if they have YouTube, click subscribe and like. So please do so. Yeah. I need to get like the 1,000 subscribers to add an advertisement, but I will not add advertisement for my class. But yeah, maybe like I can use that for like my personal stuff. Yeah, please subscribe and like, and then whenever I upload the new video, you will get the notification. Yeah. Right now I only have 368 subscribers. Yeah. And then the lab assignment could be difficult if you are not familiar with the underlying tools and then language. So we will use C extensively. Yeah. But I know that in these days, most of the students start coding with the higher level language, for example, JavaScript or Python. And then these languages are memory error free. So what that means is like if you have a runtime error, then it will show which part of the code has the error. But in the kernel programming, what you will see is something like this. It will just give some of the register information, and that's it. Yeah. Then you need to know how to locate where your error comes from. And to do that, we will use a GDB, a GNU debugger for it. And then some of you might have worked with the GDB, but it does not have like the good text user interface. But I prepared this kind of the dashboard. So if you run GDB, then it will automatically show all the registers and assembly lines, and then corresponding source code. And then you can type some of the commands in here. So it will help you to identify which part of the code the current execution stopped, and also you can identify like what kind of the function called chain and that kind of stuff in like the GDB debugger. And don't worry much, because like in the tutorial video, it describes like each steps of like how you can locate the error and then resolve the thing. Yeah. So please take a look at the tutorial video thoroughly, and when I record the tutorial video, I try to clearly deliver all the messages. So like some of the students complained about like the video was too slow. And then one of the tip of the watching the video is like you can speed up on YouTube and then play it as a 1.5x or something. Then you can save a little bit of time about that. Yeah. And then for the students whose language is, whose mother tongue language is not English. So these days, YouTube's and Google, they are doing great for like translating the verbal English recorded video into like this auto like a closed caption. So you can choose your like preferred language. And then I tried that in my mother tongue language, Korean, and then it's somewhat readable. So I presume that like that will be also applicable for some other language. So that could be one of the way to get one of the way to like make the class easier. Yeah. And then we need to read a lot of the assembly languages, something like this, for debugging purpose. Yeah. So please get familiar with the syntax, at least just for the syntax of the assembly language. So for example, move L0 4/ESP is like at the stack position 4, store 0 to there, something like that. So please get familiar with this kind of the syntax. And then in the lab, we also need to deal with the hardware-defined data structure. What that means is that we will conceptually learn about like the global descriptor table or intra-descriptor table or page tables, something like this. But these are actually implemented by Intel. So we need to learn about like how the CPU actually handles that. And then we need to match that in the software. Yeah. So we provide all the materials as like a reading material, and then we pinpoint which part to read in the lab tutorial. Yeah. So please watch both lectures and lab tutorial to get the high level idea, and then low level details, and then ask TA for help if you get lost.
Hello, can I have a quick question?
All right.
So like,
there's one question on the Zoom side. Yeah. All right.
Yeah, like I know nothing about the assembly. Will that be an issue for the assignments?
So so the question is like one of the students don't know anything about the assembly language, then would that be an issue for the finishing lab assignment? I would say no, not an issue at all, because like you can follow the syntax of the assembly in first 1 and 2 weeks. And then and then we will also only require you to write around the 20 to 30 lines of the assembly in like the lab 3 and lab 4. So you will have the plenty of time around like the first 5 weeks to get familiar to the assembly language. Yeah.
Gotcha.
So I highly recommend you to follow the supplementary material to learn about the assembly language.
Gotcha. Thank you.
Right. And then the next is about the rule of the lab assignment. So I highly encourage you guys talk each other and work in group, even if like an assignment is individual. Yeah, please work in group and then discuss each other and then discuss over Discord. And then if one finishes lab assignment, try to help them out, others out. Yeah, that's all okay. But the thing is, please share only the idea, not the code. Because the reason for doing the lab assignment is delivering, translating the high-level concepts into the implementation, and then doing that by your own. That's actually the important thing about like learning the details of the operating systems. Yeah. So it's okay to share the idea, high-level concepts of like how you can pass the hurdle and then correcting the error and then implement something, but please do not share the code directly. Yeah. So you can ask question about like my code is something like this, how can I fix it? That's okay, but do not give the answer directly as a code snippet. Yeah, that's the thing. And then in that regard, please do not copy other students' code. And then because the JOS is used by like many other universities, so you can easily search for the GitHub for the finished lab or something. But please do not use those code. And also, please do not publish your code online because I can search OSU JOS, and then there are some of the repository, and then if I were a student, it's very tempting to take a look at that and then refer the code. But by doing that, you will not learn the things correctly. Yeah. So please do not do that. And and then not just for the code, I will ask you to write a little bit of write-up for starting from lab 2. So there's no write-up for lab 1, but starting from lab 2. There will be the part of the text that you need to provide for the answering some of the questions regarding how you implement the thing, or to check whether you correctly understood concepts and details of the lab assignments. Yeah. And then same thing applies to the write-up. Please do not refer to other students to write up. So it's okay to have a little incorrect answer for that. So if the big direction is correct, then I will give the full points. So don't worry about the detailed number in the write-up. Yeah, but please try to answer with your own words. And then I'm not presuming that there's some of the students who will do plagiarize the code, but historically there were some of the students who copy the code online, and then trust me, I'm a hacker. Yeah, I'm very good at discovering that kind of thing. Yeah, so please don't do that. Yeah, so there were some of the students who got F and then take the class again. Yeah, so. And then I posted all the due dates on the calendar, but if you have some of the circumstance that you cannot avoid, and then please let me know. I will accommodate a little bit of that for the shifting due dates per each one. Yeah, but not too much, because we need to finish all the grading on the Monday of the next week of this one. Yeah, So I will set the final dates that you can submit the lab assignment as like the December 9th. So I told you that like lab 4 difficulty is much higher than the others. So it's very important to you to have like enough room for like the finishing lab 4. And then each lab is depending on the previous lab assignments. So if you cannot finish lab 3, then you cannot start lab 4. Yeah. So like please try to be on schedule and then follow this tutorial and ask PAs to finish it at the right time. And for the due dates, we will have 3 due dates. So if you submit the code before the due date, you will get the 100% of credit from the grading result. And we have like 1 week grace period to have like a 75% of the credits within the 1 week after the due date. But if you submit at the end of the term, then I will give you like the 50% of the credit for that lab assignments. But because I set the lab 4 due date as a 1 week before the last due date, so I will apply 75% for the lab 4 if you submit the code before. This should be December 9th. Yeah. So please follow the calendar on the website for the due dates. And then I set all the due dates available on Canvas so that you can also check that those due dates on the Canvas calendar. And then for the graduate students, I set the bar as 3 points higher than the undergraduate students. Yeah, but even if I do curve to lower the grading brackets, this will never change. So for the graduate students, you need to make sure that you need to get a little higher score to get the same grade with the undergraduate students. So the same thing. So lab assignments could be difficult. So please study in group. Yeah, and please try to use the resources that we provide. Watch tutorial videos and then ask questions on Discord. Not here. Yeah, and then important thing is like in the Discord we have a lab channel for each lab, and then there's a pinned message from previous class offerings. So these are like the historical knowledge base. So please try to take a look at them, and then you will easily get some hints from there. And also, don't be afraid to don't hesitate asking questions to TA or myself. Yeah. And then if you are not familiar to like the basic terminal tools, I highly recommend to visit this website. So this website is so-called missing semesters in computer science. So most of schools don't teach how to use SSH, private key, and also how to use Git, how to use some of the terminal tools such as Tmux. Yeah, but this student organized class teaches it very well. And then I also heard that from the churches of Evan, that Discord, some of the great students would like to voluntarily teach these kind of stuff during the summer and on. So please visit that website and then try to get familiar to those tools as soon as possible. And the last thing, for some of the extra adventurous students, so in each term, there are some of the students who felt the JAWS project is too easy. Yeah. So in that case, please, I will have a description that proposing your own project. So it could be doing something on JAWS, or it could be something different, but implementing their own operating system. So for example, one of our TA, Jonathan, is there. Yeah. So he came down to the podium in the first week, and then offered me that he has finished this kind of stuff in his high school, and then he would like to implement the similar operating system completely in Rust, and then he did it. Yeah, and then I appreciate that, so I assigned the 200 points, yeah, which is more than like the 100% points of the thing, yeah, for the lab, and that was fun. And then like some other examples could be JAWS. After finishing lab 3, there's another option for JAWS that you can implement paravirtual hypervisor on top of JAWS. So you can replace lab 4 as like not implementing preemptive multitasking. You can implement virtualization, and then you can run Doom on it. Yeah, so that could be fun. Yeah, and then some other things that you can do is you can implement a file system and paging in JAWS. What that means is that like we are not doing left 5 of the JAWS, and then left 5 is actually implementing the file system. And then if we implement the file system, then we can use the disk space. And then JAWS is configured to have like maximum 256 megabyte of memory, but you can use the disk space to store some of the application data that does not actually need it at the same time. So you can page out those data, and then you can actually run the program that requires more than 256 megabytes. For example, if the application requires a 1 gigabyte or 2 gigabyte, you can run that application on JAWS, and then implementing that kind of systems would be fun and adventurous. And another suggestion could be you can make JAWS to support the 64-bit CPU, because right now JAWS works on the 32-bit Intel CPU, which is a very old one. Yeah, so that would be fun. And then another fun thing could be you can port JAWS. Right now it works with the Intel CPU. You can port that to ARM CPU, then you can boot that on Raspberry Pi. Yeah. So for those students like who want to take like some other project, then please send me the proposal in like at any time of at any time of the term. But you need to have like enough time to finish the project. So that I highly recommend proposing your final project for replacing lab 4 or something. Yeah. And around the week 5 or something, but please do not consider that like you can avoid the lab 4 with the easier project. Yeah, the reason why I introduced these kind of weird but the funny thing is that like the implementing these are much more difficult than lab 4. Yeah, so these are for like the adventurous students. Any questions to this kind of having alternative project? No? Yeah. Please try to do this. This would be much more fun. And then like if someone finishes that, and then I will allocate the time at the last day of the lecture to showcase their own operating system with the super weird thing, brag about that and during the lecture time. So this is the last slide. Yeah, thank you for your attention. Lab 1 is out, so please follow the tutorial 1 and 2 to finish lab 1. So please start the tutorial 1 right away, because tutorial 1 is just for following some of the instructions to get onto the environment and then set up the environment on the OS2 or some other server. Yeah. So please start the lab immediately if you have time. Yeah. And then feel free to use Discord as your resource. So this is the end of the lecture today. And then feel free to ask any questions, because I will stay here up to like the 1:20 p.m.